These markers are tough. Now, this one might have smaller writing because I have to do 9 parentheses and a subtraction problem. And I need 4 different colors, so what other colors can I use?
Use any color.
Okay.
Just blue and black are pretty close, you know.
So I just won't write them next to each other.
Yeah.
And orange and red are pretty close, so I won't write them next to each other. Actually, nope, I'm gonna have to write lines.
Pretty sweet little poster.
What is it, clouds?
Clouds and like wind expect precipitation as long as the wind's coming like from southwest to west to north.
Wow. All right, before I do a really hard, complicated limiting reactant problem, I'm gonna do a really easy one that we can tell in our head. So these represent boxes of brownie mix. And this is going to represent eggs. So limiting reactant problems ask us how much product can be made and they ask us which reactant is limiting, which reactant is excessive. That's just the phone ringing. And how much excessive. So in other words, how much is left over, how much can we put back in the cupboard? So the first question, how much product can we make? If we use all 3 boxes of brownie mix, how many trays of brownies can we make? Kyle, I'm really asking you.
How many?
How many trays of brownies, if I use all of these boxes of brownies, could I make?
How many were there per tray?
1.
3?
3 trays. If I use all of my eggs, it takes 1 egg to make a box of brownies, to make a tray of brownies. How many trays of brownies could I make with all those eggs?
4.
So which one can I really make?
3.
How come?
Because you only have 3 trays of brownie mix.
Right. So the 3 trays can be made. That's how much product can be made. The limiting reactant is the brownie mix because I run out of brownie mix. The excessive reactant are the eggs because I have leftover eggs, and I have how many leftover eggs?
1.
1 leftover egg. So we have to do the same thing, just with chemicals that you've never heard of, with decimal points that you have to use. So for that, we have to do 9 parentheses and 1 subtraction problem. So this question 14 in the practice sheet says a really cool chemist has 10 grams of aluminum oxide and 2 grams of carbon. And the question says how much CO2 is formed. So we want to know how much of this product can be made. First of all, these questions are asking about reactants. which reactant is limiting, which reactant is excessive. So on the test, when you get to questions like that, you need to pick at least a reactant. A lot of people pick products, and it's not asking about products, it's asking about reactants. So obviously these two would be wrong answers for those questions on the test. And none of the answers should have anything to do with aluminum because it's not part of the questions. So don't even put aluminum at all in any of the 9 parentheses. Now, I do this in 4 parts. We have part A, which is going to be going from aluminum oxide to the product that we're asking about. And part A is going to tell me if I use all 10 grams of the aluminum oxide, how much CO2 can I make? Part B is going to be from carbon. If I use all 2 grams of carbon, how much CO2 can I make? Part C and D we'll have to do when we're done with A and B, but C and D answer this question. A and B, we can answer these first 3 questions. So for part A, we start with 10 grams aluminum oxide. And we have to calculate how many grams of CO2 we can make. So we need to get rid of the grams aluminum oxide. To do that, we have to get to moles. So moles of aluminum oxide are going to go on top. Those cancel. We're left with moles of aluminum oxide, but we're trying to get to grams of carbon dioxide, so we still need more parentheses. Moles of aluminum oxide can go on the bottom to cancel. And now that we're in moles of the first chemical, we can go to moles of the second chemical, which the chemical we're asking about is carbon dioxide, so that's what goes on the top. But we're trying to figure out grams of carbon dioxide. So we need another parenthesis. This label and chemical will go on the bottom. So it cancels, and then grams of CO2, which is what we're looking for, can go on the top. Then we go back, fill in the numbers. Our misses is this middle one because we have 2 different chemicals, both are moles. To get the number for the misses, use the coefficient from the balanced equation. Coefficient in front of carbon dioxide is 3. Coefficient in front of aluminum oxide is 2. Moles not in the misses, the number that goes there is 1. Grams off the periodic table. Aluminum is 26.98, but I have 2 of them. And oxygen is 16, but I have 3 of them. I'm not doing that in my head. $101.96. And carbon dioxide, carbon is 12, oxygen 16, but I have 2 of them. That's 44. So this problem says to take 10